All right, guys, Mr. Antonucci here. We're in Unit 2, Differentiation, Definition, and Fundamental Properties. This is preparing us for the AP Calc exam. Before we jump into our problem, just a little bit of facts about Unit 2. 10 to 12% of the questions will fall under the topic. Here we go, Part 1, multiple choice questions. What is the average rate of change of f of x on the interval 1 to 5? So average rate of change, f of 5 minus f of 1 all over 5 minus 1. If you plug in 5, f of 5, 25 plus 10 minus 6, so that's going to give us 29. F of 1 is 1 plus 2 minus 6, that's negative 3. 5 minus 1 is 4. So we would have 32 over 4, which is 8. The graph of f is shown above, has horizontal tangents at negative 3 and 1. Which of the following is true? So let's look at f prime of 0, which would be right about here. Since the graph is of f, the derivative is the rate of change. All we know is that the slope is negative at that point, so we know f prime of 0 is negative. F prime of negative 3 right here, it says we have a horizontal tangent at negative 3, so we know this is 0. And f prime of 4 would be at this point right here. Since the graph is increasing at that point, the derivative is positive at that point. So inequality A is going to be our correct answer. I want to take the limit of this difference quotient here. Remember, this is the limit definition of the derivative. So this is equivalent to saying what is f prime of 3, where f of x is natural log x. So f prime of x would be 1 over x. F prime of 3 is 1/3, so this is choice D. An important thing to understand is to recognize when you have a limit definition of the derivative in order to solve the problem. Here's another one. We have the other limit definition of the derivative in terms of h. F of x is sine x, and this limit represents the limit definition of the derivative again. So f prime of x is cosine x. We're not plugging in any values, so that's our answer. Let f be a differentiable function. Selected values of f are given in the table above. Use the data in the table. What is the best estimate of f prime of 3? F prime of 3 is approximately, the best we can do is approximate it using the slope of the 2 points closest to x equals 3, which are when x is 2 and 4. And the slope would be 8 minus 5, change in y, over 4 minus 2, change in x. That would be 3 over 2, which is choice D. So here we want the derivative of 1 over x plus 1 over x squared. Sometimes it's helpful to rewrite this as x to the negative 1 plus x to the negative 2. And then if I take the derivative of this, just simple power rule, bring the exponent down, subtract 1. And then you simplify that, you have 1 over x squared minus 2 over x cubed, which is the third one. Let f be a piecewise function defined above. Which of the following statements about f is true? All of them deal with differentiability and continuity. So first, is f continuous at x equals negative 2? So f of negative 2, we would have to use the bottom piece, which would be 4 minus 4 plus 3 equals 3. That's the function value, the limit as x approaches negative 2 from the left. You would have to use the top piece. And as x approaches negative 2, you would get 3. And we know that the bottom piece is going to approach 3. So since the limit and the function value both exist and are equal, the function is continuous. So that's going to eliminate C and D. To see if it's differentiable, you look at the derivative of the piecewise function. The derivative of the top piece would be 1. The bottom piece would be 2x plus 2. And as x approaches negative 2, values less than negative 2, the slope would always be 1. Values greater than negative 2, the slope is going to approach negative 2. Since the slopes aren't approaching the same value from the left and right. The derivative does not exist, and it's b. The graph of h is shown above. For what value of h is h of x continuous but not differentiable? So if we look at 2, here at 2 you have a jump discontinuity, so it's not continuous. At 3 we have a removable discontinuity, so it's not continuous. At 4 you have a corner, but it is continuous, so it's not differentiable, but continuous. And just to check, at 5, you have a removable discontinuity as well. So if f equals sine minus 3 cosine, then the instantaneous rate of change is, instantaneous rate of change is just a phrase that means the derivative. So we'll take the derivative and then plug in pi over 2. So f prime is cosine x plus 3 sine x. Derivative of cosine is negative sine. If we plug in pi over 2, cosine of pi over 2 is 0. Sine of pi over 2 is 1, so times the 3 gives us 3. Let f equal natural log x plus 2x. What is the slope of the tangent to the graph of f at x equals 3? Again, this is just another phrase that means take the derivative, plug in 3. So f prime of x is going to be 1 over x plus 2. Plugging in 3, you would have 1/3 plus 2. 2 is 6/3, so 6/3 plus 1/3 is 7/3. Let f be a differentiable function defined as f equals g times h. Use the graph of g above, and that h of 1 equals 3, h prime of 1 equals 4. What's the value of f prime of 1? So f prime, we would have to use the product rule. It's the derivative of the first function times the second, just using notation here, plus the first times the derivative of the second. And then we're going to plug in 1 for all of that. So g prime of 1 times h of 1 plus g of 1 times h prime of 1. G prime of 1 would be the slope of g when x is 1. The slope at that point, since this is a line segment, we can just do a slope triangle. You would go down 2 over 1. So the slope is negative 1. H of 1 is 3. So there we go. G of 1 is the actual function value when x is 1. So that would be 2 times h prime of 1, which is 4. We would have negative 6 plus 8, which is 2. For this one, we're taking the derivative of x to the 4th times e to the x. This is another product rule. So derivative of the first times the second plus the first times the derivative of the second. Remember, the derivative of e to the x is e to the x. Notice they also factored out the GCF, so we could factor out x cubed and an e to the x, which would give us 4 plus x. So x cubed e to the x times 4 plus x is choice C. If f of x equals 2x cosine x, then f prime of 0 is, here another product rule, but we have to plug in 0. So let's first take the derivative. So we'll take 2x to be the first function and cosine to be the second. So derivative of the first times the second plus the first times the derivative of the second, which would be negative sine. I'm going to put the negative there. So f prime of 0, cosine of 0 is 1. Sine of 0 is 0. Also, the x plugging in 0 gives you 0. So you would have 2, choice D. Let k be the differentiable function defined as k equals f times h. Selected values of f prime, h, and h prime are given in the table. What is the value of k prime of 4? So k prime of 4 would be using the product rule. So derivative of the first times the second plus the first times the derivative of the second. From the table, f prime of 4 is negative 3. H of 4 is negative 1. F of 4 is 2. And h prime of 4 is 3. So 3 plus 6 is 9. If f of x equals secant plus cosecant, then f prime is. So f prime, derivative of secant is secant x tangent x. Cosecant is negative cosecant x cotangent x. Remember, if you're differentiating and the function you're differentiating starts with a co, the answer is going to start with a negative. So this would be choice D here. Here's another one. Let h be the differentiable function defined as h equals g over f. They have values of g, g prime, f, and f prime. We want h prime of 1. So we'd have to use the quotient rule here, which is the derivative of the top times the bottom minus the derivative of the bottom times the top. With the quotient rule, the order matters because you have subtraction in the numerator. Also, it's all over the denominator squared. A lot of people forget that. So g prime of 1 is 3, f of 1 is 4, minus f prime of 1, 5, times g of 1, which is 2, all over f of 1 squared, so that's 4 squared. 12 minus 10 over 16, so that's 2 over 16, or 1/8. Choice B. Here we have a calculator allowed question. Let f be the function given by f equals cosine minus cosecant. What is the value of f prime of 1? We simply type the function into Desmos. Using function notation on the next line, we can just simply type f prime of 1, and we get negative 0.078, which is choice C. The derivative of the function f is given by f prime equals 1 minus 5 cosine of 3x squared minus 2. For how many values of x in the interval 0 to 2 is the line tangent to the graph of f of x at the point x comma f of x parallel to the line y equals 1 plus 4x? To be parallel means they have to have the same slope. So the slope of y equals 1 plus 4x is just 4. The slope of f is f prime, which they give you the function for. With Desmos, what you would want to do is graph the derivative. All right, have it right here. And then graph y equals 4. And you're looking for how many times this graph of cosine equals 4. It's 1, 2, 3. Be careful, this fourth one is not on the interval 0 to 2, so it's 3 times. Let f be the function given by f of x equals 3e to the 2x, and g is 6x cubed. What value x do the graphs of f and g have parallel tangent lines? Essentially, this is just saying at what x value are the derivatives equal to each other. So if we graph the original functions in Desmos, we have them here. Desmos allows us to easily graph the first derivative of each function with the little prime mark, and then you can turn off the first and second function, look for the intersection of those two functions, which is negative 0.391, which is this choice right here. So now we're moving on to part 2, where we're going to look at some free response questions. The graph of the function f and a table of selected values of f are shown above. The graph of f has a horizontal tangent line at x equals 2, is concave up from 0 to 5, and linear for x greater than or equal to 5. Approximate the value of f prime of 4.5 using data from the table. Show the computations that lead to your answer. F prime of 4.5 is approximately equal to f of 4.5 minus f of 4 over 4.5 minus 4. Since 4.5 is in the table, you would have to use the 2 points closest to it. Now, 3 ways are acceptable. You either use it in the point before it in the point after it, or the 2 points around it. We would have 3.193 minus 2.533 over 0.5, and this simplifies to 1.320. Part B, is there a value of x from 0 to 5 such that the limit as h approaches 0 of the difference quotient there equals 0? Give a reason for your answer. So remember, this is the limit of the difference quotient here. This limit as h approaches 0 of f of x plus h minus f of x all over h equals f prime of x. So essentially, this is asking if f prime of x has to equal 0 at some point. Well, it's going to be equal to 0 at a point where the tangent line to the graph has a slope of 0. Since the graph has a horizontal tangent line at x equals 2, and that's on the interval 0 to 5, this limit equals 0. So you would have to show a little bit of work and explain your answer in complete sentences like that. Part C, for each of the following limits, find the value or explain why it does not exist. So for I, that's the limit from the right of 0 of the difference quotient. It's the alternative definition of the derivative. So this is the derivative from the right of x equals 5. So here's 5. The derivative from the right exists, and it's equal to 1/4 because the slope of that line is 1/4. I does not exist because in that difference quotient, the numerator is going to approach 3, but the denominator approaches 0, so that would go off to infinity. In the third one, the limit overall does not exist because the left-handed limit doesn't exist. For this one, we're allowed to use a calculator. The table above gives values of the differentiable function f and its derivative f prime. Let h be the function x squared times e to the cosine 3x. Using values of f from the table, estimate f prime of 4, show the work that leads to your answer. So f prime of 4 is approximately f of 5 minus f of 3 over 5 minus 3. 4 is not a value in the table, so we have to use the 2 points closest to it. F of 5 is 4 minus -1 all over 2, so that would equal 5/2. Let m be the function defined by m equals f plus h. Find m prime of 3. So m prime of 3 is going to be f prime of 3 plus h prime of 3. F prime of 3 is 8. And then to get h prime of 3, this is where the calculator would come in. Here we have h in Desmos, so if I just type in h prime of 3, you get negative 2.06149, blah, blah, blah. You could also do 8 plus h prime of 3, which would give you the total answer there. Okay, part C, let n be the function defined by n equals f times h. Find n prime of 5. N prime of 5, we would have to use the product rule. So f prime of 5 times h of 5 plus f of 5 times h prime of 5. Now, f prime of 5 from the table is 3 times h of 5, we could use Desmos to evaluate that, plus f of 5 from the table is 4 times h prime of 5. We get our answer, negative 37.465. And finally, part D, let p be the function defined by p of x equals h over f. Find p prime of 7. So for this one, p prime of 7, we have to use the quotient rule. So it'd be h prime of 7 times f of 7 minus h of 7 times f prime of 7 all over the denominator squared. So f of 7 squared. Again, we could use Desmos to simply evaluate this. Then we just have to be a little bit careful here. So start off with a fraction in the denominator. We'll square that. F of 7 is 6, so we could square that. The numerator is h prime of 7 times f of 7, which is 6, minus h of 7 times f prime of 7, which is -2. So we get our final answer, negative 8.93 if we round to 3 decimal places. Now for this one, the temperature of a room in degrees Fahrenheit on a certain day is modeled by the function f defined above, where g is a differentiable function and t is measured in hours. The values of g of t at selected values of t are given in the table above. According to the model f, What is the average rate of change of the temperature of the room over the time interval 0 to 12? Part A, average rate of change is just the slope between the endpoints. So f of 12 minus f of 0 all over 12 minus 0. That's got to be equal to g of 12 minus g of 0 all over 12 minus 0, because f is equal to g from 0 to 12. So you would have 65 minus 87 over 12, which is negative 11/6. Therefore, the answer is negative 11/6 degrees Fahrenheit per hour. If your problem is in context, make sure you include the units. Part B, use the data in the table to approximate f prime of 10, the instantaneous rate of change of the temperature of the room in degrees Fahrenheit per hour at t equals 10 hours. Show the computations that lead to your answer. F prime of 10 is approximately g of 12 minus g of 8 all over 12 minus 8. Since we don't know the value of 10 exactly and we don't have the function, the best we can do is pick the two values closest to t equals 10 and compute the slope. This would be 65 minus 70.5 all over 4, or negative 5.5 over 4 degrees Fahrenheit per hour. Part C is f continuous for 0 to 24. Justify your answer. For 0 to 24, we have a couple things going on. We have the function f, which is a piecewise defined function. The first piece, g of t, they say that g is a differentiable function, and we know that differentiability implies continuity. So we know that much. We know f is continuous from 0 to 12. Also, from 12 to 24, the function is a polynomial, and we know polynomials are continuous on their domains. So we would have to write that out. And then the last piece is to determine whether or not the function is continuous at the point where the functions switch. So we know that f of 12 is equal to g of 12, which is 65. We take the limit as t approaches 12 from the left of f of t, which that's going to be 65 also. And then we need to take the limit as t approaches 12 from the right. From the right, we would have to use this polynomial. So we would have 12 squared minus, or 12 squared over 8 minus 3 times 12 plus 83 equals 65. Since the limit exists and is equal to 65, and the limit equals the function value, the function is continuous at 12. So the function is continuous from 0 to 24. Part D, find f prime of 20, the instantaneous rate of change in the temperature of the room in degrees Fahrenheit per hour at time t equals 20 hours. So f prime of t, you'd have to get that first, would be 2t over 8 minus 3. We're just taking the derivative of this piece, which is t over 4 minus 3. So f prime of 20 would be 20 over 4 minus 3. 20 over 4 is 5. 5 minus 3 is 2 degrees Fahrenheit per hour. Okay, so that's our CRAM review of Unit 2. Remember, you got this. Review often, practice daily. Good luck on the AP exam, and subscribe for more review.